Good morning. Playing Minecraft, Ezra? Actually might tie into what we're going to talk about today. Hi, Ava. Hello, Hike. Ryan, you didn't know there was a stream today? It's a stream every day. No, this is the last one, and it's more of a for fun one, and a final warning for those who need to get work done. Here on out, we'll probably be doing Google Meets. Send a link through Remind for different team things that we're doing. So there's nothing due in Classroom. There's nothing new. No new assignments. Hasn't been for a little bit. Just as a reminder, it is the final deadline today. This is it. Last day for anything you're missing, anything you want to revise. For those of you who are watching here with me right now, you're fine. The others who need this time, you're up against the clock. Grades will be finalized in the middle of the week. So you can check Aspen for those of you who are all set in the middle of the week. You can already know what your report card is going to look like. We'll talk about the geology of Hyrule. What's Hyrule? If you don't know, we'll have to do a little bit of an introduction. This is the Breath of the Wild version of Hyrule, not any earlier time periods. And then the rest of the week is team activities. I'll have a Google Meet at 10 a.m. to kind of go over team activities, discuss what we're doing, what you're answering. Oh dear, to what? The last part or the second part? I have like 10 basements. I'm adding a second room for the villagers I kidnap you trade with. I have 4, so I need 4 more rooms. You just kidnap people, Ezra, on Minecraft? I thought it was about building. And then a fun fact. Earth's oxygen is produced by the ocean. Your first thought may be the rainforest, but plankton, seaweed, and other photosynthesizers produce over half of the world's oxygen. And remember, oxygen only makes up about 20% of the Earth's atmosphere. A lot of you missed that question on the Friday quizzes. Said oxygen when it's really nitrogen. It is the largest amount of our air that we breathe in. It's made up of. No, you have a decent house that they live in? Oh, adorable. Alright. No other questions. Hike there. Our grand champion. So, if you're not familiar, Legend of Zelda has been around for 27 years now. First made by Nintendo on the Nintendo Entertainment System that many years ago. The first one in the 80s was released. Since then, it's been billed as an adventure puzzling game. This game, Breath of the Wild, was put out on the Switch a couple years ago, and has a pretty open area, an entire continent with a kingdom and different biomes and different areas that you can explore. Everything that is blue are called shrines. Those are little places that you can go to, solve different puzzles, fight different enemies. Big blue animals are big robots that are dungeons that you go into. And so you go around this whole continent. Everywhere you see green is where I've been on this playthrough. You traverse, you gather items, you gather strength, and the whole goal is to eventually go to Hyrule Castle and defeat the bad guy, Ganon, who's kind of trapped there by Princess Zelda. Zelda is not this guy. You are this guy. Alright? You're here to help the princess defeat the evil. Alright? So, the reason why I pull this up is because it's a pretty cool open area that Nintendo put a lot of thought into in developing the geology of a fictional place. And you can kind of do this with other fictional places and see if the author or the creators actually put enough thought into the science behind what they made and see the realism behind it and if they actually did or didn't. Alright? So, pop open the map one more time. Okay, in the southwest, we have the Gerudo Desert, Gerudo Highlands. You thought a while that Zelda was Link. You're like stereotypical person on the internet. Hyrule region is more of a colder area, so higher in latitude. Elden region has a massive volcano called Death Mountain. The Lanayru and Akala regions are more temperate, more familiar with where we are. Alright, and then down in Faron is more rainforest, and then more maritime air masses. There's a lot of different weather systems that travel through the continent. We'll talk about that in a second. Kind of go back to the beginning of the year. Alright, so we have like a desert in the southwest, rainforest in the south, temperate areas along the east coast, a volcano in the northeast, massive forest in the north, kind of goes along with the Lanayru and Akala region, Hyrule region and Tabantha region, very cold. And then you have central Hyrule, which is just an open field, open plains. Alright, so we have lots of mountains down the east coast. We have a plateau mountain range along the southwest. And then we have a bunch of canyons and mountains in the northwest. Alright, so Rainy, what is this thing? This is Legend of Zelda, Breath of the Wild. I'm showing you guys that you can look at fiction, places in fiction, to see if the creator or the author actually used science behind their decisions. So we're talking a wide open area. Right now I am in the northern region. I'm kind of near Hyrule Castle. You can see the peak right there. Behind me is the Hebrew region, the tundra, massive canyons and rifts. And I'm heading south. South would be more towards Hyrule Field, into the open plains. So why? How can we figure this out in terms of the geology? There are 3 boundaries that we look at when plates collide across our planet or separate. We can have a divergent boundary or we can have a convergent boundary, right? Divergent boundary, 2 plates are separating. Convergent, they're converging. 2 plates are colliding. So we got to look for geological features and then determine if they're divergent or convergent over divergent or convergent boundaries. Now there's 2 types of convergent boundaries. You can have convergent boundaries where there is continental and continental crust colliding together, or you could have oceanic crust colliding together. Oceanic crust is denser than continental crust. Or you can have the 2 meet. You can have oceanic crust collide with continental crust. When that happens, the denser crust slips under. So if you have continental crust coming in, oceanic crust will slip under it, and that's called subduction. So we want to look for convergent versus divergent, and then we're going to look at the different features to figure out what type of convergent boundary it is. So right away we know that there is a volcano. Volcanoes are very unique in their geology. Use Spider-Man to figure out where you are in New York. It is a pretty well-made game. So, because there's so much thermal energy, I will catch on fire. Let's fix that quickly. Is that good enough? Yeah. Pretty nice view. Okay. Again, there's the mountains to the southwest. This mountain range that Death Mountain is a part of on the east coast. That's Lorneru Sea, Pharaon Sea, Gerudo Desert's behind those peaks. Hebrew region where we came from is across this metallic thing. Okay? Yes, hike, I have. So, this volcano, the magma has to come from the mantle. How are we going to get magma from the mantle to come up towards the crust? We need to have some kind of convergent boundary. Okay? Not just any kind of convergent boundary. We can make mountains by having 2 tectonic plates that are continental, which means land masses, collide with each other and then rise up. That'll make regular mountains. Okay? We have mountains in New England, but we don't have volcanoes. Right? The Rocky Mountains are mountains, but they're not volcanoes. There's volcanoes out west in the United States, like Mount St. Helens, part of the Cascades and Sierra Nevadas. Well, how do they form? They form by a continental plate colliding with an oceanic plate. So the North American plate and the Pacific plate colliding together creates volcanoes. So if we have a volcano right here, this magma is being pushed up by the oceanic plate out to the east. So right here, this whole region, this east coast, is getting pushed up by the oceanic plate right here. And so you could say that there is a Lanayru plate out to the east of Hyrule, and that we can call this the Hyrule plate is being pushed up because the Lanayru plate is slipping under it. So Nintendo designed this continent based on two plates colliding right here. Lanayru plate, Hyrule plate. Hyrule plate goes up, Lanayru plate goes under, subducts, some of the magma gets trapped and is pushed up with the land mass, and you get a volcano. So there is a potential to have volcanoes in these other mountains besides this one right here. You only done 98? Well, I'll be honest, like, I did use a map online to kind of finish out the last 20 or so, because I was having trouble finding them. So that solves this whole eastern portion of the continent. One boundary, convergent boundary. And you have the ocean plate, oceanic plate, subducting under this continental plate that we're flying over right now. And yes, even though I left the volcanoes, they're still really hot because hot air rises, right? A little convection. You can see the rocks and material getting pushed up anyway. So how about the western edge of Hyrule? Where do those mountains come from? Because there's no ocean over here. But we do have mountains, so you do need a convergent boundary. But we have a canyon here. And canyons form when two, or rifts form, not the Grand Canyon. Grand Canyon form differently, but rifts, continental rifts, form when two plates diverge. Two continental plates diverge. So we have that here, but we don't have anything here. We just have some high mountains and a desert. So kind of what I'm getting at, you have these two really unique areas, but there's no rift and there's no ocean here, so how did these mountains even form to begin with? Well, we have to work backwards and say that they formed. They definitely had to form by a convergent boundary. They had to be two tectonic plates that were continental in nature. That's how you can get those mountains to rise. But there's no evidence of the older plate. This is very similar to the Rocky Mountains. The Rocky Mountains are right in the middle of the North American plate, but there is no boundary anymore between the plate. So, how the Rocky Mountains form? They form by two old ancient plates called the Kula and the Farallon plates that subducted under the North American plate, and then the Pacific plate took their spot. This happened millions upon millions of years ago, alright, in that ancient plates moved under the North American plate and created the Rocky Mountains. We don't really see many traces of those ancient plates anymore. On the current crust, you would have to do a little more of analysis, almost like forensics of geology. So the Pacific plate has replaced these old ancient plates that moved under North American plate, created the Rocky Mountains that we see right in the middle of the North American plate, where there's no boundary or no convergent boundary. There used to be, but no longer exists anymore, because of the Pacific plate moving in to take its place. So, very similar to what we have here. These are old mountains, a lot of mesas and plateaus because of erosion by water and wind. Old mountains are worn. Mountains actually get shorter over time. due to erosion, weathering. And so we know that these mountains are a lot older than those mountains that we just came from across central Hyrule. The volcano's over there, right where my head is, and those peaks next to it. So these mountains are much older. They had to form by an ancient convergent boundary, kind of like the Rocky Mountains did. But that does not solve this area, because there's a rift. That means there's a divergent boundary. So the ancient collision that happened here, that no longer exists, helped form these mountains. However, there is a plate out here past the Hebra plate. I don't know, we'll call it the Termina plate, that is actually diverging from Hebra. So these mountains formed by this ancient collision here, but then that plate is moving away, and that creates the boundary, the out-of-bounds rift that you see all around the map. So if I could kind of draw it out, I don't think I can. I'd actually have to get a screenshot, but you have the Lanayru plate here, out to the east. You have the central Hyrule plate here. You have the Gerudo plate, which is moving in and converging into the Hyrule plate. And this Hebra area is just being pulled and diverging from an unseen plate off to the northwest. We'll call it the Termina plate. And what's really interesting is, after you do all this, you look at the geology. Well, what about the water? Hyrule has a lot of water, starting with the wetlands here, and then it kind of drains down to the Lake Hylia, and then down into the rainforests. Well, just like any watershed, water is going to drain to the lowest point. You guys are in the big river watershed, I think, and go to the ocean. And that's what you see here. A lot of moisture is going to come over Death Mountain and those Lanayru mountains. It's going to drop its moisture this way, so the wind is going to come from east to west in Hyrule. Drop its moisture here. It's going to drain down to Faron. And then there's going to be no more moisture as it passes over the mountains here, and that makes Gerudo a desert. So not only can we figure out the different plates, Lanayru, Hyrule, ancient Gerudo plate that really no longer exists anymore, and then this Termina plate over here, we can also figure out the weather, and that wind in Hyrule goes the opposite way than it would in North America. North America, we say the wind goes from west to east, the weather travels west to east. Here in Hyrule, the weather travels overall. There would be a jet stream and weather pattern from east to west. And then it drains down into the sea. Collects. Across the fields into a lake. And that lake eventually drains into the ocean. Now, because we have a desert and a rainforest kind of close together, tropical area, well, the bottom of the map probably receives a lot of direct radiation throughout the year, direct sunlight, which probably means this is closer to the equator on whatever planet Hyrule is on. This region is very cold. So it's higher in latitude, so it must receive more indirect light. So really, you're looking at one hemisphere of one side of the planet that whatever this place is on. So, in all reality, this is a very small planet, because you can traverse this whole thing in probably, what, an hour hike? You go from north to south in real game time. But gravity works like it normally would on Earth. So if the planet is much, much, much smaller, but gravity works the same, then you must have a lot of mass packed down deep into the layers of the Earth. So, this planet is small, not much bigger than the moon, and has very, very, very dense metals down in the core. I don't know, maybe it's made out of osmium, the most dense element we know of. So not only can we kind of figure out where the plates are, we can also figure out the weather patterns, and then the layers themselves kind of infer that there's a lot of mass packed down deep down inside Hyrule in order to make gravity work the same as it would on Earth. The planet, yeah, is very, very dense. These stupid bats. So again, you could take this with anything that you are really interested in. You interested in Minecraft? Like Azra's playing? Well then, was the map that was generated what you're playing in? Does it have certain mountain ranges and caves? Those caves have lava in them or water in them. Maybe that's how the caves were eroded or weathered out, hollowed out. You can look at if there's weather patterns. I don't know if there's weather patterns in Minecraft. A bunch of you play Minecraft. So you can look at the map and see if it's based on real physics or geological physics, geophysics. I would definitely say Nintendo did, and I've never really looked into it to confirm it, but obviously Nintendo took a lot of care in designing this open world. They actually followed geological principles and meteorological principles, and they need to, because I mean you have the weather down below and the temperature and heart rate, so they made a real world for you to explore, which is pretty cool. So I'm excited for the second one. Maybe next year. Well, see, now it's raining. Raining because I'm in the tropical portion of the planet. I'm near the equator. Alright, any last questions or comments? They both complement each other. They don't compliant each other. So, rest of the week are little team activities, little things you can post on the Duck Pond Padlet. We'll have a meet each day to kind of talk about that topic that is posted Tuesday through Friday. There'll probably be a mighty meetup Thursday or Friday. I don't know which day we're going to plan on for yet. And that'll be the end of the year. And then you guys get to move on to the high school. Alright? Have fun playing Minecraft. See you guys tomorrow.